without further ado, I would like to introduce our presenter, Raj Krishnan. He is the Industry Digital Strategist at Microsoft, and he has a great presentation to share with us today on how we can turn our data into knowledge with AI-powered search, uncovering critical business insights. And I'm going to let him tell you all about that because I don't know yet. So take it away.
All right, something before that though, okay? I have climbed the highest mountains, I have run through the field only to be with you, only to be with you. I have run, I have crawled, I have scaled these city walls, these city walls, only to be with you. But I still haven't found what I'm looking for. But I still haven't found what I'm looking for. I have kissed honey lips, felt the healing of fingertips, burn like fire, this burning desire. I have spoke with the tongue of devils. I have held the hand of a devil. Warm in the night, I was cold as a stone. But I still haven't found what I'm looking for. But I still haven't found what I'm looking for. I believe in the kingdom come, that all the colors will lead into one, lead into one. Yes, I'm still running, but I still haven't found what I'm looking for. But I still haven't found what I'm looking for. But I still haven't found what I'm looking for. But I still haven't found what I'm looking for. All right, now to the presentation.
Thank you, Raj. That was awesome. I just want to, yay, that was great.
Okay, so I will share my screen. I thought it's late in the afternoon, so maybe something different. I'm sure you had enough content all through the day. So let me share my screen. Let me know if you can see it. Yes?
Yep.
All right. Okay. So I asked Ben when I wanted to do the presentation, I gave him a couple of options. And so this was his choice. So if this is not of interest, you can blame it on him. So knowledge mining. So what do we mean by that? And I think it's particularly relevant considering Umbraco and your content management system. We live in an age, it's no longer, it's about, is there data, right? It's a question of too much data and it's scattered all over the place. Can I effectively use the data in a timely and useful way? That's what is the big challenge is. I don't want to, I did not identify the person who said this because I kind of don't like this person. He's an arrogant, know-it-all person. But I thought this was an interesting. Initially, I thought it was very deep, but then I realized it doesn't make sense. Particularly, there are also unknown unknowns. But the reason I brought this is that there is so much out there, things that we know, things that we do not know, things that we want to know. And how do we harness all this and use it for useful, decision-making purposes? Right? That's the biggest challenge. I got this latest statistics. Can you believe it? In an internet minute in 2020, in 1 minute, there are 1.6 million swipes in Tinder, right? 194,444 tweets in 1 internet minute. Right? We are just bombarded with information. Look at the statistics, it's mind-blowing, and it continues to grow. But what's of relevance to us is that 80% of this business data is unstructured, right? And the loss of the employees from information search is close to $14,000. I used to run a call center. We try to capture structured data. For example, in the contact center, in the satisfaction, you ask people and you ask them, well, why are you happy with the product, or why are you unhappy? Then we'll have 4 or 5 typical reasons, and we want them to fit into that category. And if they did say something else, we capture that, we put it in the comments or put it as a text, which no one looks at it. And most of the rich content lies in the comment, right? It's like I consider this typical to a developer doing a unit test, right? When we do a unit test, we build tests that will pass or things that we know could fail, but we never could know things that can happen by exploring. So unstructured content and things are all over the place. Sometimes we capture them, sometimes we don't capture them, but even if we capture them, we do not know how to use them. So that is a biggest challenge. And they're all over the place, right? It's just in papers, in documents, particularly in the government offices. I just read an article in Chicago Tribune last week that said that the Freedom of Information Act, people, even they are so rude when you go and ask them because they don't know how to find it. So they say it'll take you 5 to 7 weeks to get a response from them. And they wait till the 7th week because they have so much data. It's not structured, it's not organized, it cannot be searched, but they are obliged to give it under the Freedom of Information Act because there's no way for them to kind of put some kind of a tangible way of getting the data. Right? And the Harvard Business Review article puts it very well, right? The innovation may be locked or not known because a lot of these things are in spreadsheets, PDFs, and documents, not in SAP, not in Dynamics. They're all in content scattered all over the place. And 82% of the people say, yes, it is a major issue trying to get the data. So that brings us to our topic. How can you turn data into knowledge? And particularly with the democratization of AI, we have so much, it's a lot easier to use a lot of these language processing, text processing, image processing, cognitive services. How do you use all that? And what can we do with both structured and unstructured data and bring it to, in a cohesive manner for us to make decisions? One thing we must appreciate, in spite of all the data sciences, the human brain and the human power is very hard to imitate. Like we can look at 3 different documents and pull what we need and unify them. That's not something that's very easy to do because we have context. We know what we want, and we look for specific things. The idea is, how do you use AI to build that human skill? Now, the biggest thing about AI is once we teach it, then scaling becomes a lot easier. I can look at 3 documents at one time, but I cannot look at 15 documents and extract all the things that are there, right? We are limited. But we have those fuzzy cognitive skills. That's what we want to use to see how we can bring those unstructured data and make something useful out of it. So when we say knowledge mining, that's what we are talking about. What we are talking about is, get your documents. It could be forms, it could be PDF, it could be images, it could be a NoSQL database, it could be SAP, doesn't matter. Bring it all in together and then try to make valuable information from that so that we can make decisions. So it's available in a timely manner, and it's available in one place. So I don't have to log in and get the SAP order number and go and look for another SharePoint search, find out where is the document. I want it all brought to me in a contextual manner to make some decisions. So that's what knowledge mining is about, right? There are PDFs, there are images, there are audio files even. How can I bring all of this together, scan it, and if it's image, do an image recognition. If it's text, extract the text. If it's a handwritten text, do OCR. If it's a form, extract the fields from the form, and then create an index, create a search index, and then questions like, okay, what's the, I want to know what are all the GDPR documents that I should be aware of. What should it do? It should know the metadata. This is GDPR data. This is about Germany. It's stored in a blob storage that's in the German data center, or if not, it's not. So it brings me all the things that I need and gives me that relevant information. Same thing. I just want to know, give me all the contracts that will be expiring next week. It should go and index it, look for the document, look for the expiry date, and then say that, okay, here are the 10 documents, and I click on the document, and the document should be visible to me. So I bring intelligence to this unstructured data by creating search indexes, by cracking the documents and building that knowledge around it. And it is now possible. So I just want to kind of start with a little demo that might give you some impact, some way of seeing what this is. So let me just show you. So this is something that Microsoft did. When the JFK files became available, you could, we took all these documents, and this site, let me see, how can I hide my top thing? Oh, let's see. Okay, no. So this site is available, but and I'll put the link later on. So if I put Oswald here, what it does is it searches the entire document. So what we did was we put all those documents that were available, publicly available, we digitized it, we put it in the blob storage, and then we ran our cognitive services. So you notice here, the Oswald is available in an OCR document. This is a handwritten document, but it is there, it highlights it. Then I can say, I want to know where these are tags that were extracted from those texts. These were all PDF documents, handwritten documents, images. We scanned all of them, took the metadata, extracted all the text, extracted the phrases, identified all these entities here, and I can actually say, okay, I want to know both the John F. Kennedy and Oswald. Obviously, there'll be a lot more documents. And then it's also possible, okay, if I click on this Oswald, it'll actually take me to the document. This is, you can notice, this is on the left-hand side is the actual document, and the right-hand side is where we did the scanning to get the document, and it highlights, every time I move, it shows where that word appears on this document, right? So this is an example of how unstructured data can be indexed and searched, and then you can get to the document as you say this. You can think of many cases like paralegal or people looking for documents based on certain keywords and categories. All this can be done using AI and scanning and text recognition, OCR and image and all that. So this is an example. So if you look at what's behind this, this is what we're doing behind the scene. So what we do is we, in this particular case, we put everything in a blob storage in Azure, and we read that. Then we use the cognitive services, things like text extraction, key phrase extraction, handwriting extraction. And when we use the computer vision to analyze the image to see what's there in the image, even face detection if it's a celebrity, or if you want to hide the face because of the privacy issues, we can even do that. And then if you look here, all of those things, irrespective of the type of document, Word, Excel, PDF, all those things, we create an index. And then we use additional terms where what they call cryptonyms, that we also try to extract certain terms that was used by CAA so that we can index them by those terms and pivot on those facets as well. Once it is done, the application is nothing but just a web application. But all those things are available in Azure, and then you make the API call to get the index, and you click on it. The app that you saw was a result of thousands of documents scanned, OCR, and index being created. So behind the scene, this is what happens, where we crack open the document, then we add the cognitive skills. And when I say cognitive skills, it's things like a key phrase extraction. What do I mean by key phrase extraction? If I said, hey, I went to restaurant A and the food was excellent. Now, the key phrase extraction is restaurant A, excellent, right? So those are because those are the things that are relevant. Now, if I do a search, I want to know anything where the food was good or above good. I could do those kinds of searches because it's indexed to do this. Now, this cognitive skills, out of the box, we provide a lot of skills, but you can also write your own custom skills. When I say custom skills, I can send a text and you can write your own extraction. Okay, I'm looking for contracts, or I'm looking for certain terminology, and then index those so that you could create your own classification models. Microsoft is doing a lot of things for example, in healthcare. Actually, let me show you that demo using pre-built healthcare terminologies, because that's already available. So let me, so this is another site that we built as part of the COVID. And if you look at this data came from Semantic Scholar. They collected all the data. But what we did is we made it useful, to me, frankly, because you can look at it. I can look at it by journal, by search. And like, for example, I will type in something that in the COVID, so HEMORR. So I can do this and look for and enter. Now it filters all the documents which contains this. Now there is another neat thing here, is what we call semantically similar terms. As usual, the British can't spell their thing, so they have a different way to spell this. So I'll add it. Now, as soon as I do that, look at the number of documents. It increased because now it's looking, based on the index, is looking for the presence of the words that both hemorrhagic and hemorrhagic, in spite of the different spellings, and pulls all the documents. And not only that, if I do this, now if I go to this, here's another cognitive service in action. It creates an abstract for you. So it goes through the body and uses language processing and creates an abstract for you, from those documents. And not only that, I can also do the relationship between these terminologies. So with this, now I can look at, okay, for this word, I have these categories, and let's say I want to look at the systems or science. And all this is done without you doing any programming, because it's using healthcare text analytics. It indexes every word and tries to find, things. So if I look, like, for example, if I add fever, now it adds the fever. Now, when I want to know who wrote something about fever, so I could now go to another facet and like say, let's look at the authors who have done this, because I want to narrow it down visually, searching for, okay, probably I'll pick anybody, Alex, right? So now I can go back to the document search, and it will now filter all the documents that meet all these criteria. Now, all this is done without writing a single piece of code. All we had to do was get all the journals, we index it, we use the healthcare terminology to create all these facets, we use the abstract using cognitive search, and all you need to do is build this application. You're calling the API and creating the screens that you want to do. So this is another example of how data is being turned into knowledge. So when we say in the knowledge mining with the search, these are all the things, right? You take all the documents, then you put it through AI in Azure. By the way, these are all configurable. The only time you're going to be writing code would be if you have your own custom entities and you want to do custom words to extract. Otherwise, out of the box, we provide organization entity extraction. We even provide translation. You can say, okay, take this, translate it into Spanish, and it'll do the translation behind the scene. And original document will be in Spanish, and you can have a translated document in English. All those are built-in services that you could leverage to build this. It can even check the sentiment. Is what was the review, positive or negative? And even it can even look for PII, personally identifiable information, to say, okay, this has got social security number, this has got your phone number. So it's got a lot of built-in AI capabilities. The end goal is for us to build a searchable index that allows me to pull the information that I need in my application without having to go to 10 different places or not even knowing that that document exists. Even if that document exists, how am I going to get the specific information? I have to read through the document. So this takes away all those things, creates the indexes, creates the linkage between indexes, and brings all of them, one from SAP, one from unstructured content, and brings it all into your application so I get the information that I need. So it's very powerful in terms of turning those unstructured things into decision. So since this is a marketing thing, I'm not going to go into the thing, but I have a little show of how it is done. So here you'll go to Azure Explorer, and it looks for many sources to get the data. And so it'll say, okay, where is the data? Pull the data. And if the data is not in any one of those resources, we can write an API to pull the data from, let's say, Umbraco or any other storage to get the content, to get the documents. And once that is done, then the magic happens where you say, okay, these are the things that I want to pull. And if it's custom things like entities, you can easily build this. If it is, you have your own custom, there is a little bit of work here. But once that is done, this is where you will create the application. Like here is an example, because it pulls all the locations. I can look for all the restaurants in a particular location. Once I index all of them, build a map, and then take advantage of all this unstructured data. And the biggest thing to me, the biggest thing is none of this requires you to spin up a machine, no infrastructure. Of course, you have to pay for the usage, but there's no other headache, and it's scalable. So if I want 10,000 documents, I take a smaller chunk of the resources. And as I grow, I pay for usage. And all the Microsoft data cognitive services are available to you when you build this. If you want to do OCR, you can do the OCR. If you want to do image recognition, you can do that. All those services are part of this cognitive search capabilities. I just show you some things. Again, it's from a Harvard Business Review. On the left top is you have structured, unstructured, things like NoSQL and others. And then the goal is to bring it all together and create usable data for decision making. And on the right top corner, you see that a spreadsheet is one of the biggest source of data. and of course, PowerPoint presentations and PDFs. So this is where most of the data lies, right? And this cognitive search can actually open all of these documents and get the data that you want. And then this is one of the biggest things that organizations are doing. On the bottom left, you see 88% of the organizations are doing something or other for knowledge mining and knowledge extraction. And just for cost perspective, I just wanted to give you an example. If you had about a terabyte of data, and if you're going to be OCRing about 10,000 pages a month, your cost is going to be roughly about $1,000 to run this. But no headache of servers, anything. All of them are based on the services that you use. So for about $12,000 a year, you can actually, of course, thing is that you have to build the apps. So, but a lot of the APIs are available. So there'll be some development effort when you want to build this, the cool things that I showed you on the, like the JFK and other things. But all the AI and indexing and all that is done for you behind the scene. One more thing, I don't know how we are doing on time. The new thing we had added is pretty interesting, is what I call semantic search, right? A lot of the times we go to search, it doesn't understand our intent, right? On the left-hand side, if I say moon landing, anywhere the word moon appears, if it's a Chinese moon restaurant, that'll also show up. But in the semantic search, what we do is it knows your intent. If I'm talking about landing in the moon, it's scattered around the sentence, but it knows the context and it'll only pull information that's contextual rather than anything that contains the search term that you use. And I can just kind of show you a quick demo as to how that works. So here, this is an example. And if you look at my settings, I've turned off all the semantic things. So if I do this, right, it first of all doesn't understand I misspelled search, and it goes from, and the data source is Microsoft document. It brings something that's not very, very relevant. However, if I go to thing and I want to compare and I want to do spelling, I want to take care of spelling, immediately look at how it changed, right? This is without the spell search, and this is with spelling. And then I want to do semantic ranking. Say, give me the relevant things first. As soon as you do this, it goes for anything that says what's Azure Cognitive Search. And then if I add, I want answers, it immediately highlights the answers, and I can even highlight the caption. So you can compare between a typical search that doesn't understand your context, that doesn't understand spelling mistakes, versus a full semantic search where it knows exactly what you want and surfaces the most relevant information to the top. So that's the semantic search, which I wanted to highlight. Finally, probably, I want to leave some time for questions. Forms is another cognitive skills that we offer. What it can do is you can put all your forms in there. It'll learn. I recently did a project with a pet food company. One of the things they wanted to do was when they get supplies from when they're vendors, they want to know which vendor's ingredient goes into what product so that they can trace the vendor if there is a recall. So what we did was we scanned all the invoices to identify, created a QR code, stuck it on the pallet, and then read the QR code, and then make sure that there is traceability from the time something lands to the product manufactured. The core piece of that was hundreds of invoices coming every time to the loading dock. We use the form recognizer to scan and immediately create data and create the labels that can be used instead of manually entering them, making mistakes. So this form services is something that scans your forms, identifies the data, and then you can associate the form with the data, so I easily pull this data from there. So when you do knowledge mining in Azure, this is what you get, right? You get completely fully managed, no infrastructure, and you get all these cognitive services like form recognizer, speech, image recognition, entity extraction, sentiment analysis. and then you get to build your own application. We don't provide you out-of-the-box solutions, but what you can do is get the content, create the indexes, and then customize the application by calling the API that has all the rich information that combines all of them. Finally, this is National Poetry Month, and I just wanted to leave you with a beautiful poem by Maya Angelou. I know the obvious differences between each sort and type, but we are more alike, my friends, than we are unalike.